Alrighty here. Pretty much the same idea as the last problem, except now we're given the hyperbola written in parametric form. So let's go ahead and see if we can piece this together. So first thing I want you to remember is that the Pythag identity involving secant and tangent is secant squared minus tangent squared equals 1. So if you think about this then as a hyperbola, since tangent is with the y term, that's telling you that your y expression is negative, which means that this has to be a horizontal hyperbola. Okay, well then where do we go from here? Well, let's go ahead and take this equation and solve it for secant. I wrote it as secant of t. Let's solve it for secant of t, and then we can substitute into this equation right here. Or you can memorize a formula. It's up to you, but memorizing stuff is poopy. So let's go ahead and solve this for secant. So if I have 3 plus 5 secant t, I need to subtract 3 from both sides. And then what do I have? Well, then I'd be left, I've moved that 3 over. Then I'm left with a 5 secant t, so I need to divide everything by 5. So then that would give me secant of t, but I don't want secant of t, I want secant squared. So I square that, and then I could plop that right into that spot. And then we need to subtract the y stuff. So the y, I'm going to do the same way. I'm going to solve for tangent of t. So I'm going to add 2 to both sides. So I'm going to get y plus 2. I am going to then divide both sides by 4, and then I'm going to square it. So I can plug it straight into that piece right there, and that equals 1. And there you have the equation in rectangular form. Let's sketch this graph real quick. My center is going to be at 1, 2, positive 3, 1, negative 2, right there. The 5 underneath the x is telling me, hey, let's go 1, 2, 3, 4, 5, right there. There's a point. Let's go 1, 2, 3, 4, 5. There's another point. The 4 underneath the y is telling me, hey, let's go up 1, 2, 3, 4 from the center, and down 1, 2, 3, 4 from the center. And from this, we can get our box. So let's dash in our box. Let's draw in our asymptotes running diagonally through the corners of the box and perfectly through the center as well. And let's recognize that this is opening horizontally, and so we end up with this little feller right there. And again, we're drawing it to the best of our limited ability. And so we get that thing right there. We've sketched the graph, we've written the equation in rectangular form. We need to find the equation of the asymptotes, which is pluck your y stuff, y plus 2 equals plus or minus some slope times pluck your x stuff, x minus 3. What is my slope? Well, since this is horizontal, that means that A is horizontal and B is vertical. But also just look at the equation. From that, we can see that we're going up 4 and over 5. So rise is 4 over 5. So there are our asymptotes. Last thing we need to do is find the coordinates of the foci, which are going to be like there and there somewhere. So recognize the x value is changing, the y value is staying the same. But what do we know? We know for a hyperbola that c squared equals a squared plus b squared. Remember it as Pythag. So c squared equals our a squared, so a is 5, so a squared is 25, plus our b squared of 16 equals c squared. So 25 plus 16, what is that? I don't know. 25 plus 10 is 35. 35 plus 6 is 41. So c is the square root of 41, which means our foci can be written as boop, 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 boop. The x value is changing, so from the center, the x value of the center is positive 3. We need to add and subtract that square root of 41, comma, the y value is the same as the center, so negative 2, and we're done.